field due to uniformly charged infinite plane sheet applying Gauss's theorem. Now let us consider a thin infinite plane sheet. This is a plane sheet surface. Let us say this is the plane sheet, right? It extended up to infinity in all sides. This is charged with plus sigma. That is, it is uniformly charged with the surface charge density plus sigma. This sheet is uniformly charged with plus sigma. Now we have to find out the field near this surface. That means if this is the surface plane sheet, then we are going to find the field at this point, just near the surface. Let us say this is the point P, where we have to find out the or calculate the electric field intensity. Now if we want to apply Gauss's theorem, then we have to take a Gaussian closed surface. Now take the Gaussian surface as a cylindrical surface with cross-sectional area ds surrounding P. This is a pillbox type closed surface. See here, if this is the surface, closed surface, this plane sheet everywhere. Now this is the point where we want to find out the field. At this point we take a surface area, let us say circular surface area ds, and on the bottom, that is opposite side of the plane sheet also ds, then take it as a cylindrical surface. This is the cylindrical surface, closed surface. That means we take the Gaussian surface to a cylindrical surface of cross-sectional area ds. Cross-sectional area ds. Now charge enclosed in this closed surface is what? Q enclosed will be equal to sigma into ds, because this ds we take here at this point, and this is the cylindrical surface. Then surface area inside the cylindrical closed surface contains charge is ds, and sigma is the charge per unit surface. Therefore charge in ds surface area is sigma into ds, which is the charge inside this Gaussian surface, which is Q enclosed is equal to sigma into ds. There is a symmetry. Since the plane sheet is infinite, plane sheet is charged with plus charge, then field lines due to this surface charge distribution will be perpendicularly away from the plane sheet. That means if this is the plane sheet, then field lines will be perpendicularly away from the sheet. Clear? Similarly, in the down, perpendicularly away from the sheet. That means we can say the field lines are like this. And since this is infinite, therefore field at this point will be equal to field at this point. Infinite. This is the symmetry of the problem. Now, according to Gauss's theorem, we know closed integration E dot ds, that is the total flux through this Gaussian surface, will be equal to Q enclosed, that is charge enclosed by the Gaussian surface, divided by epsilon 0 if surrounding region of the plane sheet is vacuum or air. Now you can divide the closed surface into three surfaces. One is this plane surface S1, another is this plane surface S2, and third one is curved surface S3. Therefore, we can write this closed integration is equal to integration over S1 E dot ds plus integration over S2 E dot ds and plus integration over S3 E dot ds, which is equal to Q enclosed, that is sigma ds divided by epsilon naught. Now see here, the direction of this surface is perpendicularly out, that is upward direction, and E is also in the upward direction. Therefore, for surface S1, it is EDS cos 0. Similarly, for the surface S2, the direction of surface area is going away, and also the field direction is going away, that is the angle between surface area and field is 0. Therefore, this can be written as EDS cos 0. But for the curved surface, for this curved surface, the surface area is perpendicular in this direction, that is you can say horizontally parallel to the surface, but electric field is perpendicularly away from the surface. That means at every point the angle between electric field and the surface area direction on the curved surface is 90 degree, that is normal. Or you can say this can be written as EDS cos 90 is equal to sigma ds by epsilon naught. Now E, we have E, this is everywhere same, therefore E, and integration ds, the total surface of this area which is also ds, that means EDS cos 0 is 1, here also EDS, and this cos 90 is equal to 0, which is equals to sigma ds by epsilon naught. Or you can write 2E ds is equal to sigma ds by epsilon naught. Therefore, E equals to sigma ds divided by 2 epsilon naught into 2 ds, that means sigma divided by sigma ds by epsilon naught divided by 2 into ds, that means sigma by 2 epsilon naught, ds cancels, 2 epsilon naught. This is the field near an uniformly charged infinite plane sheet, and this can be written as in vector form sigma n by 2 epsilon naught, where n is the unit vector perpendicular to the surface and going away, of course perpendicularly outward, that is away from the infinite plane sheet. If sigma is plus, then it will be away. If sigma is minus, then it will be towards the surface. That means if the plane sheet is charged with minus sigma, then field lines will be towards the plane sheet. Let us say there is two infinite plane sheet. Let us say there is two infinite plane sheet and both are charged with plus sigma. Let us say this is an infinite plane sheet charged with plus sigma, and this is also an infinite plane sheet, infinite charged plane sheet and charged with plus sigma. Then first we draw the field lines for this plane sheet. This will be away from the sheet in this region, away from the sheet in this region, also away from the sheet. This the lines of force due to this plate. Clear? Now we are going to draw the electric field lines due to this charged infinite plane sheet. For this case also, the field lines are going away from the sheet because it is also charged with plus sigma. Going away, right? These blue lines are the lines of force due to the lower infinite plane sheet. And since both are charged with plus sigma, then field at every region will be same. But in this region, the field lines are headed same direction. That means in this region, field will be E equals to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. Sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. That means sigma by epsilon 0. Here also, E will be sigma by epsilon 0 added. But in between the two plane sheet, what will be the field? 0, because same but in opposite direction. Blue lines are in the upward direction but black lines are in the downward direction. Therefore, field in between the two infinite plane sheet charged with same type of charge will be 0. Another problem. Actually, this second problem will be used in the further discussion, in the further study. Let us say this is an infinite plane sheet charged with plus sigma, and another plane sheet, we take another plane sheet which is charged with sigma but negatively charged infinite plane sheet. This is negatively charged infinite plane sheet. Then the field lines due to this plane which is positively charged will be, field lines are going away. In this region also, the field due to this plane sheet will be going away. And field due to this plane sheet which is charged with negative charge. Clear? Negative charge. Then field lines will be towards the surface. Field lines will be towards the surface. That means in this region, field lines will be along this direction, and in this region, field line will be towards the surface. In this region, field line will be towards the surface. Then what happens? In this region, field line are opposite directions. That means field at this region will be 0. Field at this region will be 0. Sigma by epsilon 2 epsilon naught minus sigma by 2 epsilon naught is 0. But in this region, E equals to sigma by epsilon naught. And it is directed from plus to minus. That means the plate which is charged with plus charge to the plate which is charged with negative charge.